You're a walking miracle of engineering, a trillion-cell civilization held together by hope, chemistry, and a lot of luck. But being alive is a messy business. Every second of every day, your biological machinery is grinding away, and like any factory, it creates waste. Proteins fold into useless tangles, microscopic power plants break down, toxic garbage piles up in the hallways of your cells. If this trash isn't cleared out, your cellular city eventually chokes on its own filth. In humans, we call this aging, disease, and eventually, death. But nature has a solution, a brutal, ancient, and deeply effective reset button. Autophagy, from the Greek for self-eating. To save the whole, your cells must begin to devour parts of themselves. It sounds like a horror movie, but for billions of years. From the first single-celled organisms to the primordial soup to the duck sitting in your local pond, it's been the only thing keeping life from falling apart. The catch? In our modern world of infinite snacks, sugary lattes, and 24-hour drive-thrus, we've almost entirely stopped doing it. We're a civilization that has forgotten how to take out its own trash. So, how long do you actually have to stop eating before your cells start the great cleanup? When does the biological janitor finally pick up the broom? And what happens to your internal world when you push the self-eat button? Before we look at the clock, we need to understand what we're actually waiting for. Inside your cells are tiny structures called lysosomes. Think of them as vats of acid and enzymes, miniature stomach-shaped incinerators. During autophagy, your cell identifies a piece of junk, perhaps a broken protein that's gumming up the works, and wraps it in a double-layered bubble, called an autophagosome. This trash bag then floats over to the incinerator, fuses with it, and everything inside is melted down into its basic building blocks, amino acids and fatty acids. But here's the clever bit. Your cell doesn't just throw this away. It uses these recycled parts to build new structures or to create energy. It's the ultimate zero-waste system. In 2016, Japanese scientist Yoshinori Ohsumi won a Nobel Prize for figuring out how this works. He showed that without autophagy, life basically breaks. We get sick, we grow old faster, and our brains fill up with protein clutter linked to things like Alzheimer's. For the first 12 hours after your last slice of pizza, your body is essentially a spoiled king. You're swimming in glucose, the simple sugar that fuels your brain and muscles. Your pancreas is pumping out insulin, a hormone that acts like a loud-mouthed construction foreman shouting, "Build, grow, store. Don't worry about the mess, we'll clean it up later." As long as insulin is high, the autophagy button is locked behind a glass case. Your cells are in growth mode. They're drawing energy from your blood and the sugar reserves stored in your liver, known as glycogen. During this phase, the biological janitors are basically on a coffee break. They see the trash piling up, but the foreman, or insulin, won't let them start the incinerators because there's too much fresh work to do. Around the 12-hour mark, the mood inside your body changes. The glucose party's over. The fresh logs have stopped arriving. Your liver's sugar vault is looking dangerously empty. This triggers a tiny, ancient sensor inside your cells called AMPK. Think of AMPK as the energy police. When it notices that cellular energy is low, it panics. It pushes the foreman out of the way and flips the switch from building mode to survival mode. This is the metabolic shift. Your insulin levels crater. Your body begins to tap into its long-term energy storage, your fat. As fat is broken down, your liver produces ketones, a high-octane backup fuel for your brain. Now, things get serious. By hour 16 to 24, the whisper of autophagy becomes a roar. Because the body hasn't received external food for a full day, the cells become incredibly picky about what they keep. The autophagosomes start hunting for bigger game, damaged mitochondria. Mitochondria are the power plants of your cells. When they're young, they're efficient, but as they age, they become leaky, spitting out toxic molecules called reactive oxygen species that damage your DNA. Through a specific process called mitophagy, your cells identify these broken, smoky power plants, wrap them up, and melt them down. They're replaced with shiny, new, efficient mitochondria. If you have the willpower to push past 24 hours, you enter the repair zone. This is where the biology gets truly sci-fi. By now, the self-eating is so intense that your body begins a process of immune reset. When you fast for this long, your body realizes it can't afford to feed these zombies. It breaks them down for parts. But here's the magic. When you eventually eat again, Your body uses stem cells to grow a brand new, younger, more efficient immune system from scratch. But wait, if autophagy is so great, why don't we just stop eating forever and become immortal, shiny-celled gods? Because, like anything in the universe, balance is everything. If you fast for too long, the self-eating stops being selective. Your body runs out of trash and starts eating the furniture. It starts breaking down your heart muscle, your skeletal system, and your vital organs. This is the line between fasting and starvation. One leads to longer life. The other leads to a very permanent end. So, what have we learned? We live in a weird moment in human history. For 99% of our evolution, we didn't have refrigerators. We had forced autophagy. We ate when we caught something, and we recycled ourselves when we didn't. By eating from the moment we wake up until the moment we sleep, we have essentially banned the janitors from our cellular city. You don't need to go on a 10-day water fast. You just need to give your body a break. Maybe it's skipping breakfast. Maybe it's a 24-hour reset once a month. Your cells are ready to clean house. They have the bags, they have the incinerators, and they have billions of years of experience. All you have to do is nothing.